Good afternoon and welcome to today's Industry Week webcast, Virtual Problem Solving, a Roadmap for Manufacturing Operations, sponsored by Kepner Trago. My name is Jill Jesko and I am Associate Content Director with Industry Week. We have joining us Sam Bernstein, Practice Leader, Andrew Marshall, Regional Managing Director, Chad Player, Consultant, and Philip Thompson, Vice President of Global Growth, Client Services, and Marketing. And with that, Drew, welcome, and the floor is yours.
Thank you so much, Jill, for that great introduction, and thank you very much to Industry Week for hosting this webinar today on virtual problem solving. I'm Drew Marshall, the Regional Managing Director for Kepner Trago's North American Operations. Thank you so much for joining us on today's webinar or for listening to today's webinar. At Kepner Trago, we believe that people drive results. What kind of people? People who are curious, ask great questions, make decisions based on facts, and are empowered to lead. They remain focused under pressure and act confidently to do what needs to be done, whether face-to-face or working remotely. At KT, we provide a unique combination of training and consulting services designed specifically to get to the root cause of challenges clients face and permanently address their organizational challenges. Our systematic, data-driven approach to tackling organization challenges will be to create meaningful opportunities for any company looking to improve quality and effectiveness while reducing overall costs. We deliver measurable results, and our clients appreciate us for it. We look forward to sharing with you some of how we do that today. And now over to our presenters. Gentlemen, take it away.
Hello, everyone. This is Sam Bernstein, and I think we've got a great agenda for you today. We'll start off by talking about what is virtual troubleshooting. KT has a very clear definition for virtual troubleshooting, and we want to make sure we're all on the same page with the discussion this afternoon. Then we'll provide an introduction, which I think will help you appreciate the impact and true value of virtual troubleshooting. We'll share a story called the Albatross Anomaly, which will give us an opportunity to walk through a case study. Then we'll talk about a preferred Kepner Trago structured troubleshooting methodology. And we'll conclude by talking about the virtual problem-solving roadmap, which will make all of us a little better tomorrow than we are today at virtual troubleshooting.
So troubleshooting, when virtual is the only option. So we need to put a definition to what that means. So when we say virtual troubleshooting, what we're defining here is that the troubleshooting facilitator is not able to be at the plant. Okay? He's off-site for some reason. However, there are resources at the plant that can do things for him still. Okay? That makes troubleshooting more complex when the troubleshooter is actually not there for that. So as we know, this past year, the pandemic has caused many plant managers lots and lots of stress, right? However, the plants still need to be operational, productive, and efficient. So what we're going to discuss today with you is how troubleshooting can be done when you can't physically be in front of what needs fixing. Hey, Phil, what was one of the earliest virtual problem solvings that you can think of?
51 years ago, and about 210,000 miles from planet Earth, 3 astronauts heard a loud bang, and they knew immediately something was wrong. That's when these infamous words were spoken, "Houston, we've had a problem." The Saturn V rocket has 3 modules. The command module, where the 3 astronauts sat, the service module that carried the oxygen tanks, the battery packs, and other life support systems, and the lunar module, which was that part of the spacecraft that was designed to travel to the surface of the moon, and then the top part would bring back the 2 astronauts. There was no chance that the mission to walk on the moon could be accomplished. There were much bigger issues that needed to be confronted now. The explosion had occurred in the service module, and the oxygen tanks had been ruptured. The engineers at Mission Control immediately switched into virtual problem-solving mode. They knew that now it was going to be extremely difficult to bring back these 3 astronauts to Earth safely, because the explosion, there was not enough air or energy or water for these astronauts to survive the return to Earth. Luckily for these 3 astronauts, all the engineers who worked at Mission Control had attended Kepner-Trago's problem-solving and decision-making training. And now they engaged in a virtual problem-solving project from over 200,000 miles away. First, they held discussions to clearly focus on what was wrong and what the priorities were. The fact that the astronauts didn't have enough clean air to breathe was one of the major issues. In the pre-discussion rounds, they gained a clear understanding of the problem. And based on those, they were able to define the issues, assign focused roles and responsibilities, map out resource planning requirements, and then coach and guide the astronauts to gather the information and materials they needed to solve the problem. Removing carbon dioxide was a major concern. There were lithium hydroxide canisters that remove carbon dioxide from the spacecraft, but the square canisters from the command module were not compatible with the round openings in the lunar module. And on top of that, the lunar module was only designed to support 2 men for 2 days. And now it was being asked to care for 3 men for 4 days. So after a day and a half, a warning light came on and said that the carbon dioxide had built up to a very dangerous level. Mission Control devised a solution involving the use of cardboard and tape and plastic to connect the lithium hydroxide pellets that were on board the lunar module to the air purification system of the command module. Despite the fact that the engineers were hundreds of thousands of miles away, using the right method, good planning, professional execution, they were able to solve the problem and get the astronauts back to Earth safely. So you see, problem solving might be more complex when it's done virtually, but it's not impossible. The engineers at Mission Control used KT's problem analysis method, including focused clarification discussions, careful planning, and alternatives testing. Ultimately, using the KT method, they were able to find the right tools, the right technology, and the right technique to devise the best solution to solve the problem. They had to work in a virtual environment, and yet they still made the right decisions to get these 3 guys back to Earth safely. All this happened 51 years ago, and with a separation distance between the expert problem solvers and the teams on site being over 200,000 miles. So while it perhaps wasn't the very first virtual problem-solving engagement in human history, it certainly was the furthest away, and clearly a very challenging one because it involved the survival of 3 men in outer space. And that is the rest of the story.
You've heard a little bit from Kepner-Trago already today. Now we'd like some input and we'd like to hear from you. This is a poll question. We'd like you to pick one of these 4 responses. The question is, how often have you used virtual troubleshooting in the past 12 months? Please select one of the 4 responses. We'll give you about 15 seconds. Never, 1 to 3 occurrences, 4 to 6 occurrences, or greater than 6 occurrences. And again, that's over the past 12 months. Okay, Chad, can we take a look at the results? Interesting. What you see here is never is at 17%. It looks like over a third of the group with us today has been at 1 to 3, and greater than 6 at almost 27%. So clearly, over 80% on this call have been involved in at least one virtual troubleshooting experience, and it looks like almost 50% have been involved in 4 or more. So everybody's where they need to be. We're on the right subject with the right people, and we'll now talk about the actual process itself.
So what you see in front of you is what we're calling a virtual problem-solving guide or roadmap, if you will. And good virtual troubleshooting, like anything, has 3 parts: the definition, plan, and execution. On the define part, certainly we have 2 project plan discussions that we recommend everyone do when doing virtual troubleshooting. And these pre-shop project discussions are there to figure out, get some information, to gather some information. Some of that information might be just to confirm that we actually have a problem first. just to make sure we're all on the same page on what that problem is. Some of the other discussions might be around what could go wrong with the virtual troubleshooting facilitations and to catch any issues that might come up. After that, we're going to get into some planning with some roles and responsibility identifications, resource requirements, the data gathering, what kind of data are we going to need. We're going to get into the actual strategy of what method we're going to use. From that method, we're going to come up with some hypotheses for those. And then certainly, we're going to get to some root cause confirmation for that. So I want to share with you a story called the albatross anomaly. The company is called Genco. It's a manufacturing plant, and they supply stamp panels to the military for their drones. They have a total of 6 stamping machines in this plant, and 4 of those stamping machines are being used for this military contract. I walked myself into this plant one morning, and I look around, and everything seems to be pretty quiet, right? Usually by this time in the morning, those machines are stamping away. Parts are being moved around by forklifts. And as I'm walking down one of the aisles, one of the senior operators calls me over, and she says to me, "Hey, we're having some issues with some panels for the Albatross drones." She shows me one of the panels, and I can see that there's rough patches on multiple locations on this panel. And I would kind of describe those rough patches as sort of a checkering pattern on the surface of the panel. And I start to ask some questions around, when did this start happening? She explains to me, it started about 8:30 this morning, and 3 of the 6 presses are having this issue. And at this point, I had just got off the phone with the customer. We plan to increase production. So a really bad time to have a defective product coming off our presses. So at this point, I know I need to get this problem solved and quickly. I can't risk losing this contract, so I decide to call the senior troubleshooter, RJ, and get him involved in this troubleshooting process. After calling him and explaining that I need him back at the plant, he reminds me so eloquently that we are still in a pandemic era and that he's not allowed to travel back, so he can't be there. However, the option to solve this virtually is always there, and I totally agreed. However, this virtual troubleshooting meant that most of RJ's senses that he used to do troubleshooting when he's at the plant are going to be pretty much non-existent or impaired significantly.
What's unique about virtual troubleshooting from a remote environment? Well, you're really under tremendous sensory deprivation. If you think about it, you're not physically in the plant. So for all those on the call today, think about this a minute. You can't see the machine. You can't hear the noise from the machine. You can't smell anything that's abnormal from the machine. You can't feel vibration from the machine. In essence, you are at a severe handicap because of sensory deprivation. This is why you need to really leverage the apprentice troubleshooters that you have at the plant that you would be working with. It requires tremendous cooperation, and those people who I'm calling apprentice troubleshooters at the plant are really your cooperative witnesses, and they are picking up on the sensory deprivation that you have. This is where you want to utilize all the skills that you can acquire from technology, tools, and people to help make up for the fact of the sensory deprivation. Remember, if you're on site, you have unlimited access to the data, and you can literally go to the machine, you can go to the plant floor, you can look at the deviation, you can handle all these issues firsthand. But in a remote virtual troubleshooting environment, you no longer have that luxury, so you've got to rely on the apprentice troubleshooters at the plant themselves. Now let's see how RJ is going to continue to start to troubleshoot this problem, knowing that he is in fact in a remote virtual troubleshooting scenario.
So RJ starts some pre-planning discussions, right? He's starting to request some information about the issue. First thing that RJ asked for is he wants some pictures of the panels that have these rough patches on them. In addition to those, he wants some pictures of panels that do not have these rough patches on them. And what he's trying to do is actually confirm that we actually have a problem and that it's not just a variation in that's acceptable within our process. So now confirming that we have a problem, panels have rough patches, how do we confirm we actually have that problem?
Take a look at this chart. You see a should level of performance, you see an actual level of performance, and in this picture you obviously see a deviation between should and actual. Keep in mind, when you're confirming if you really have a problem, you first have to understand what the expected or should level of performance is versus what the actual performance is. Kepner-Trigo defines a problem with three very simple, succinct questions. Is there a deviation between should and actual, as is depicted with this picture? Is cause unknown? And do I need to know cause to take meaningful action? If you in fact say yes to all three of those questions, you have in fact confirmed that you do have a problem. Confirming that there's a problem is really key because if you think about it, we all have limited resources that we work with every day, whether it's virtually or at the plant. So it's absolutely critical that we're working on the right problem at the right time with the right people. Now let's check back in with RJ to see how he continues to focus on this problem that we have in fact confirmed.
Not to waste time and resources, RJ starts to put together a high-level plan. It's going to talk about the data he's going to need to solve this rough patch issue. And remember, the fact that he can't be on site means that technology is going to have to take place of his senses.
I talked about sensory deprivation a little bit earlier, and we've all acknowledged that technology can help serve as a substitute for troubleshooting from a facilitator's lost sense standpoint. Ideally, in the world of Gemba, you would go to the spot, you would go to the actual place and the actual part so that you could firsthand see more information about the problem. But in this instance, as we've depicted with this picture, what we're really talking about is how can I help myself from a see, hear, feel perspective? Maybe it's something like an iPhone camera that'll give me the video that I need to see how the equipment is running and what the defect looks like. Depending on the nature and scope of the problem, you might need something more elaborate like a borescope. If you're into trying to hear the noises with the equipment or with the defect, you would perhaps use something like a microphone or maybe even something as sophisticated as a decibel level meter. From a feel standpoint, if you're talking about dexterity, you might be looking at something like a vibration meter or something like a thermal gun. The point is, you need to be very, very explicit with these technological tools because it's one thing to have them available and at your possession, but remember, you're virtual and you're remote, so you want to use these tools and instruments with the apprentice troubleshooters that are in fact at the plant. So you need to provide them with guidance and direction on what it is you're looking for. Don't make it too complicated. Perhaps it can be simplified. Something like a mobile phone could provide you with what you need, or even having a process engineer walk around the plant with a PC and videoing information that you want to acquire in that way. When you're looking at the video, sometimes you will look at measurement data, cycle time data, failure reports. These are all different types of data and information that you can gather, and you can gather this virtually, but again, you have to work with the apprentice troubleshooters at the plant to acquire this information. Remember, when a problem occurs, it's not necessarily where the problem is that is also where you're collecting data. So in a virtual environment, there's always gaps in knowledge and understanding as to what the problem really is. Let's go back now and see how with technology it can help. But remember, technology alone can't solve problems, so there's other resources that will in fact be needed by RJ.
So far we've been walking you through this troubleshooting engagement for RJ. He's been following what we call a troubleshooting facilitation roadmap. He's held 2 pre-project discussions so far. And in each one of these meetings, he's getting a clear assessment, like we pointed out. What is the deviation? What is the should? Is the root cause known? And do we need to know to take some sort of effective action for that? All of those has been affirmably answered. And now he's thinking about what type of technology can he employ, like Sam referred to, in terms of what he'll be able to measure using those different tools. Now he'll be defining the roles and expectations. He's looking for resources that he may need to solve this problem. Maintainers, maybe a reliability engineer, process engineer, and certainly operators, all may be needed to perform some kind of activity at the plant during this structured root cause analysis. These resources should be familiar with the machines, the products or the process, and they all should have some indication of the RCA process that pulls all this relevant data together. These resources may become his personal robots that will use this technology and help him collect and confirm the relevant data.
If you look at the hard hats in this picture, what we're really doing is depicting what I call different functional skill sets within your organization. You may in fact need different people to help you depending on what type of problem you're working on. Maybe it's a chemist, maybe it's a reliability engineer, maybe it's a process engineer. Again, depending on what type of problem you're dealing with, you need different resources of people to help you. When you're trying to work with the apprentice troubleshooters at the plant, and again, you're in the remote virtual environment, collaboration is key to leverage the information and knowledge you need as a virtual troubleshooter to solve the problem. You need to work very closely with these apprentice-type troubleshooters, and you need to be very intentional and specific and direct while providing patience and guidance with the type of information you need, where you need that information, and what kind of data you want to gather. You also want to make sure there's teamwork involved from a visibility standpoint. So even though they're at the plant as the apprentice troubleshooters and you're working remotely as the virtual facilitator, you want to be able to share visibly the information that you're asking of them and that they're gathering for you. The key is to always make your thinking and their thinking collectively visible. Now, with that in mind, technology and people, as tremendous a resources and key as they both are, without a solid plan in place, you're still not going to be able to get to where you need to solve the problem and find root cause. Let's take another look at the type of planning that RJ is developing to ensure troubleshooting success.
So certainly in addition to those resources, RJ's plan is going to include the activities that need to take place to solve this rough patch issue. This plan outlines the resources, the technological tools that may be needed, but it's also going to tell him what kind of documents he might want that he's going to need to review or analyze. The testing equipment as well, what he's going to need. This plan he's putting together is going to need to be given to the site as soon as possible, and he wants to do this to prevent wasting time and resources on gathering these artifacts.
We're certainly emphasizing the power and value of pre-planning with this slide. When we talk about pre-planning, we want the virtual troubleshooting facilitator to do that pre-planning with the problem sponsor, the problem owner, and the problem stakeholders. It's very important that you, in fact, have more than one pre-planning meeting. And the reason for that is things are constantly changing with a particular problem that you're dealing with. The information may be altered or it may be different from one point in time to another. And you need to exercise tremendous clarity in order to get successful execution and implementation on managing the problem itself. So keep in mind that body language is something you would normally have the benefit and value of if you were working hand in hand or right next to the machine with the operator. But because you're virtual and remote, you don't have that opportunity. And as difficult as it may be, because you're remote, teamwork is even more important in the pre-planning scenario than it would typically be if you were in a meeting in the same room with people. You want to be intentional, specific, and you want to continue to collaborate in a very, very team-oriented way. And keep in mind, one pre-planning meeting is not enough. You probably need a minimum of 2 and maybe 3, depending on the nature of the problem and the difficulty of that problem. Now, let's think about questions and a process that will help you get to root cause.
RJ is a certified problem facilitator, KT certified problem facilitator, and he's going to use the process he knows as PA. This process is known as problem analysis for that. And he's going to adapt this process to a virtual environment. So being that this is a deviation type problem, the panels at one point had no rough patches and now they do, RJ proceeds to use the problem analysis methodology. And this methodology is going to help him collect the relevant data he's going to need. It's going to give a structure that helps make thinking visible, and it's going to aid the team through the troubleshooting process.
So the real benefit of taking this Kepner-Trego problem analysis process is you're trying to make up for not being on site, and you're going to use process and the methodology to help get you to root cause. Things like communication, common language, and listening skills are imperative to team success. In an ideal situation, the virtual troubleshooting facilitator would not only know the problem-solving methodology, but the apprentice troubleshooters would also be equally familiar with the same problem-solving methodology. Thus, you have a common language and you have a framework in a structured format that everybody can work to. You're going to ask very systematic, process-oriented questions in a very specific way, and you're going to also exercise the ability to ask both open and close-ended questions. And the key is to have at the plant the apprentice troubleshooters to be people who have some degree of subject matter expertise, so that when you're using this process and this methodology, you're asking the right people the relevant and right questions at the right time. Now, technology can be used as a substitute to replace your senses, and we've talked about that throughout this presentation. But even such a simple example as instructing a process engineer to go to the machine and take a picture of the broken equipment, or take a picture of the defect, or even asking an apprentice troubleshooter to draw a schematic or make a diagram of the defect itself is very helpful as a way to make up for the fact that you're not at the plant, but they are. Questioning is key to this process. Let's take a look at the questions that are going to be used to help us get to root cause.
Part of RJ's plan is going to include a series of questions that's going to collect data that's going to help explain why the panels with rough patches are being reported at specific locations within the plant and not at other locations. For example, presses 3, 4, and 6, but not 5. Being virtual, RJ asks for a map of the plant that shows these locations. The plant also requests pictures of the panels to show where on the panels the rough patches are occurring. When was the first observed date and time, a time stamp for that? When since that time was it observed? He also is going to ask for a video in real time on the panels being pressed, so he knows what's happening to the panel when the rough patches are occurring. How many panels have the rough patches, and how many of those rough patches are on each panel? And then he'd also like to know what's the size of a single rough patch for that. And he's going to put that into a format that keeps it visible for people to see and ask relevant questions on. And those questions have to do with what? What's the object and what's wrong with the object? It also asks questions on geographical locations, the where for that. It's going to ask questions on the when data, the timing, if you will, for that. And then there's going to be some questions around the number of that tells us really how big this problem is. And the key here is to make this document as visible to the team as possible. So sharing your screen, making sure people can see it correctly so they can have the ability to ask questions around this.
One of the most effective ways to gather this data and to ask questions is to make sure you utilize everybody in their skill set as a valuable resource. So oftentimes when we facilitate these virtual troubleshooting events, if the apprentice troubleshooters at the plant are comprised of, let's say, 5 to 6 people, we might assign different groups of 2 people per group and ask John and Sally to go out and gather the what information in the is and is not on the chart you're looking at. We might have Frank and Susie look at where data, and another group look at the when data, and another group gather the extent data. But as I share that with you, it's not enough to ask people at the apprentice troubleshooting level at the plant to just go get that information. That's where your job as the virtual facilitator from a troubleshooting standpoint really comes into play. You need to be very specific and, again, intentional with people on directing, for example, the operator to go to press number 3, take a part out of press number 3, make a visual depiction of that, whether it's a picture, whether it's a video, whether it's a diagram. Again, emphasizing sharing the information, making it visible, but being very clear with people on what it is you're asking them to do. You may ask a process engineer to provide a map of a plant. And while providing that map of the plant, literally circle physically where in the plant press 3, 4, and 6 are located. So keep in mind that when you're working in this type of a situation, it requires tremendous teamwork and tremendous clarity from the virtual troubleshooting facilitator to the apprentice problem solvers, because again, you have sensory deprivation and you are in fact counting on those people at the plant to help you overcome that obstacle. At this point, we're now ready to get all the data together and look at the identification with our hypothesis of possible causes.
So after collecting that relevant data in that format, RJ and his team start to develop hypotheses around what might be causing the panels to have these rough patches. And some of those included that the blanks could be too brittle. The ovens they use to harden the panels is contaminating the panels. Worn tooling improper forms and shapes the panels, and improperly inserted blanks don't really accept the panels, accept the stamps for that. So from those hypotheses, we're going to do a little testing given upon the data that we have. And if you look at dirty ovens contaminating the panels, that one, given the data we have, the spec data we have, that one doesn't make sense because we have been seeing some of those panels have rough patches that never go to an oven. We're seeing them after first stamping. So there's no way that one could be one of the true cause. Worn tooling, improper forms and shapes. Again, why not all the panels and why not on press 5? So there's some pretty good assumptions there. Improperly inserted blanks, don't accept it. Again, I would question why not all the panels and why not on press 5? So it seems like the brittle blanks, given the hypothesis we've had, seems to be our most probable cause for that. After we have this most probable cause, we don't really know for sure, so we have to do the last step in the process, the methodology, and that's really confirming whether this is the true cause or not. And so there's some things we can do to confirm, and in this case, we're going to conduct an analysis on the carbon and metal content of these blanks to try to confirm that they actually are too brittle for that. So really in conclusion, let's review this roadmap we've been talking about, this virtual problem-solving roadmap.
Pre-project discussion. I've literally had clients ask me, Sam, are you serious? Do we really need 2 pre-planning meetings? Isn't one enough? Quite frankly, again, depending on the scope and nature of the problem, you may need more than 2 pre-planning meetings, but we would suggest you have at a minimum 2 meetings to double your efforts. You may ask why? Well, remember, there's so much you have to do virtually from a troubleshooting facilitator standpoint that you don't have the luxury to do when you're at the plant. You have to talk about the technology that you're going to use. You have to talk about the logistics. You have to talk about the structure that you're going to employ, the expectations that you and the client want from this troubleshooting experience. What are the expected outcomes? How are we going to communicate and provide feedback to one another? These are all things you want to talk about and plan with the stakeholders, the sponsors, and the problem owner.
So in virtual troubleshooting, it is critical that defining the roles and responsibilities and expectations of those people back at the plant to solve this problem, and also to look at any maybe potential problems that might occur during this process is hugely important.
Resource requirements and planning. We all struggle with having enough resources to do the jobs that we want to do. Our focus here is to deal with results-based troubleshooting, not activity-based troubleshooting. So with that in mind, you have to be sensitive to the resources you have and the limitations of those resources. It's not only people, but it's time and it's money. It's the use of technology and what types of that technology. It's test equipment. It can be so many different things, so it's imperative that you consider all those resource requirements and planning up front. Remember, if you fail to plan, you're literally planning to fail.
Understanding what methods and tools we're going to use to gather this data. Again, it needs to be visible. It needs to be communicated to the problem-solving team members beforehand. This is how we're going to go get that data.
The problem analysis strategy selection is key. You need to have that common language, and ideally, as we've previously mentioned, you want the virtual remote facilitator to have the same skills and be able to pass that process and that strategy onto the apprentice troubleshooters at the plant. In order to do that, you want to make sure that everybody's on the same page with the process you're going to use. The reason I'm so excited to use the KT problem analysis process is because not only does it help you get the root cause, but it oftentimes keeps you from doing silly things because you look at the data and facts that you've gathered with the specification, which was shown earlier, and it becomes quite clear about not only what I should do, but things that don't make sense and thus I shouldn't do.
When performing the actual virtual facilitation itself, virtually, patience is essential. You've got to be able to give people time to do things, the discipline, persistence, and they really need clear direction and guidance from you to get those possible causes identified and evaluated.
Determining the probable cause is a very objective and fact-finding exercise. In this presentation, you saw where we looked at 4 different causes, and quite frankly, 3 of those just did not make sense because they did not support the facts based on the information we knew about this case. Now remember, we were able to be successful, and we did that in a virtual environment. So when you're determining the probable cause, you simply want to make sure that you're sticking to the facts and you're being objective, and it's not just a brainstorm or a guessing game, but it is objective and fact-based.
And certainly once we have that determined most probable cause hypothesis, we still need to confirm root cause, which means we need to do something to it to absolutely make sure by verifying assumptions, putting it into a sandbox, using some test and equipment to try to figure out actually proving that it's actually the root cause.
Remember, once you know root cause, you're still not done. Once we know root cause, we want to say, okay, what's the best problem solution to eliminate this problem from ever occurring again? And you may have different options and different alternatives to look at. But the ultimate goal after you have root cause is to select and implement the best problem-solving solution.
So now that we've just walked you through the most important pieces of this problem-solving process virtually, what questions do you have?
Okay, thank you very much for that excellent presentation. A few of you have already submitted questions, so we are going to jump right into those. I would ask, however, while our presenters are addressing your questions, please take a moment to complete the feedback form on the left side of the lower toolbar. And with that, our first question is, what interpersonal approaches do you use to manage impatient leaders who want to go fast rather than deliberate and systematic? For instance, they want you to be less methodical.
I'd like to take a crack at that. This is Sam. As I mentioned earlier, what we're really talking about here is not activity-based problem solving, but results-based problem solving. When we work with leadership and management in many organizations, they're oftentimes evaluating the success by the amount of activity that's done rather than the final result. So what we really do is we tell people sometimes you have to first go slow in order to go fast. And what I mean by that is you have to have the discipline and the mental focus and persistence to first, as we articulated in this presentation, confirm what the real problem is. And then once that problem is in fact confirmed, then you use a methodology and a process to gather the information and facts. Oftentimes clients will say, well, we don't have time to do all that. But what I'm amazed about is when they call us back a month later, they have time to go back and review the problem again and again, because they haven't made the commitment and the discipline to use process to begin with.
Okay, thank you. Our next question comes from Scott, who asks, as a leader, how do you stimulate creative brainstorming when identifying possible causes in a Zoom-type conversation? It's much harder than in a room together.
Yeah, I can speak to that one a little bit. Virtually, as everyone knows, is difficult at best to try to get people on the same page on a computer screen. The key there is, certainly when you're generating possible causes, there's other tools that we can use to try to generate those type of things. Fishbone diagram, Ishikawa diagrams, cause and effect diagrams, things like that. But you have to have those up on a screen to keep people focused. Yeah, that's probably the number one thing I'd say is make sure you keep things up on a screen, people focused, and assign them tasks to do while you're doing it. It needs to be a pretty good way to keep them involved in sort of the brainstorming, creative juices going on for that. So that would be my suggestion.
Okay, thank you. Our next question comes from Mary, who asks, do you have suggestions for navigating highly sensitive manufacturing situations where IP is a concern? For example, no pictures, videos, etc. to share.
I think that's a great question, and I think legitimately that's one of the reasons why you have those pre-planning meetings. Different clients have different expectations and different requirements, as well as proprietary information. So again, that's why those pre-planning meetings are so essential. All that information needs to be surfaced in advance of the actual virtual troubleshooting event itself. And there are different ways that that information can be shared, but perhaps in situations that are unique from one client to another. So we've had experiences where we're only allowed to do certain things, that we have certain limitations with clients, and those are usually worked on from an individual standpoint. But those can be achieved. The key is to be talking about those in advance and not waiting till the morning that you're trying to actually conduct the virtual troubleshooting event.
Okay, thank you. We are going to move on to our next question, which is, on average, how many virtual troubleshooting events might it take to solve a problem?
Well, that depends. I'll give you that answer to start off with. It depends on the problem you're trying to solve. In my experience, 6 or 7 isn't an uncommon number. And it all kind of is based on what kind and how quickly you can get the data back to you. If it takes a while to get the data, or you've got to search for it, it's going to take longer. But really having those pre-project discussions about what data is needed, that's going to minimize the number of sessions you should have for that. So that's where I would focus most of your attention is what data do I need, who's going to go get it, and what are we going to do with it once we have it.
Okay, our next question is, and you may have addressed this a little bit, but what is the most important phase of this whole process?
When you say phase, I assume you're talking about the 9 steps that we shared earlier?
I suspect you're right.
Okay, and I know we're in a virtual scenario here, so it's hard to get total clarification, but all 9 steps are obviously important and critical to the success. But I feel very, very strongly that pre-planning is where you really have to start. I don't know if it's the most important step, but clearly it's the first step. And if you don't do a good job in the pre-planning, which is why we want to double the effort there with at least 2 of those pre-planning events, there's so many things that are so critical, as I said earlier, around communication and expectations and deliverables and timing and resources. So I would personally say, if I'm going to work with a client in a serious virtual troubleshooting event, we've got to make the commitment to the pre-planning first. And if the organization doesn't want to find the time or energy for that, we're probably not going to be set up very well to be successful for them and to get the root cause of the problem. Particularly, and that's what's unique about virtual troubleshooting versus face-to-face, we always recommend pre-planning and face-to-face troubleshooting facilitation as well. But because of the complexities and the challenges we've talked about this afternoon, I think it's even more imperative to have pre-planning in virtual troubleshooting facilitation events.
Okay, thank you very much. Our next question. What do you think is the greatest challenge as a facilitator in a virtual troubleshooting event?
I'll take this one. So there's lots of challenges in virtual. I mean, there's challenges just doing them face-to-face, but in virtually, to me, one of the greatest ones is getting the intent of the questions I'm asking and getting the right technology involved to get that intent satisfied for that. People are always a challenge when doing virtual troubleshooting or any troubleshooting at all, but in the virtual world, like I say, you can't have that interpersonal connection with those people to get to know the intent of the questions you're trying to get to. So again, having a common methodology that everyone understands and they'll know the intent of the questions beforehand, hugely important. Will certainly minimize those challenges.
Okay, thank you. And our next question. Who should be invited to those pre-project meetings?
I think it's a range of people within the problem-solving process. You want to talk to, again, the stakeholders, the owners, the sponsors of the problem. And some of those people, if not all of those 3 areas, should be invited to the meeting. But you also probably want to get some people who are going to be people you're going to work with from a data gathering and collection standpoint. And by the way, if you're ever going to solve a problem, I talked about Gemba earlier, you go to the actual spot, you go to the actual part, you go to the actual machine. So in those pre-planning meetings or in those discussions, you probably want to involve the operator. The people that are closest to the problem are some of the ideal people that you want to talk to from a pre-planning standpoint, as well as people who are going to support you with the guidance and the direction of the implementation of the technology that you're going to use throughout the virtual troubleshooting event.
Okay, thank you. With that, I would like to turn the reins, so to speak, back over to Drew. Drew, do you have any final words that you'd like to share in conclusion?
Yes, I do, Jill. Thanks so much. Thank you to Chad, Sam, and Philip. Thank you, Jill, and Industry Week for hosting us today. And thank you to those of you who joined us today or who have listened to the recording of this webinar. We trust you found it valuable. The last thing I will say is for over 60 years, we at Kepner-Trigo have empowered thousands of companies to tackle millions of their most pressing challenges they face. And if we can save millions for a manufacturer, restore IT service for a stock exchange, and yes, help Apollo 13 get back from space, we can help your business achieve success. Thank you, and have a good day.
Okay, thank you. I would like to take a moment to thank our speakers of this afternoon, Sam Bernstein, Drew Marshall, Philip Thompson, and Chad Player. And of course, I'd like to thank our sponsor, Kepner-Trigo. And most of all, I'd like to thank our fine audience for their attention and their great questions. And on behalf of Industry Week, I'd like to say thank you for your attendance and have a productive remainder of your day.
Thanks, everyone. Good luck to you going forward.